All right, we are jumping into 9.3. 9.3 is going to be rotations. We've already talked about translations, which are isometries. We've also talked about reflections, which are isometries. And now we're going to look at rotations. Just glance at a rotation here. Is it going to be an isometry? A rigid motion? Yes. Why? It's not changing shape or size. So they are congruent. The preimage and image are congruent. Okay, this next question just says, what are the differences and similarities about AA prime, BB prime, and CC prime when you're talking about a translation versus when you're talking about a reflection? So here would be a translation. And if we look at AA prime, BB prime, and CC prime, there's AA prime, BB prime, and CC prime. And then if we go over and look at a reflection, let's say this was reflected like that, and then we look at AA prime, BB prime, and CC prime, AA prime, BB prime, CC prime. What is the same with a translation and a reflection? What is true about AA prime, BB prime, CC prime for both of them? Yes, that is correct. They are parallel. So if you look at AA prime, BB prime, CC prime, they're going to be parallel with both those. What's the difference? With a translation, AA prime, BB prime, and CC prime are not only parallel, but they're also what? Congruent. Are they congruent for a reflection as well? No, they are not. So that would be a difference that I would have. Okay, let's go ahead and jump into what a rotation is. It's like insanely hard to give a definition of a rotation without using the word rotation. So what I'm going to do is I'm going to put it in a different way. A rotation is a transformation with two characteristics. The first characteristic is that the distance from, here's the point of rotation right here, the distance from the point of rotation to any point must equal the same exact as from the point of rotation to its prime. So from Q to V needs to be the same distance as Q to VV prime. Q to W is going to be QW prime, QU is going to be QU prime. So those distances have to be the same. Does anybody have any questions about that? The only other characteristic of a rotation is that the measure of the angle between, let's say, VQ and V prime has to equal the measure of what? What's that? Going from V to Q to V prime, if that was 60 degrees, what other angle would have to be 60 degrees? W going to Q to W prime. So the angle between the other points would also have to be 60 degrees if the first one was 60 degrees. And going along with that, with our diagram here, that would have to also equal the measure of what angle? We've already done V and W. What else do we have? U. So you would have U, Q, U prime. So all the angles are the same. If all those angles are the same and all the distances from V to Q and V prime to Q and then W to Q and W, if those are the same, then you know that you're going to have a rotation. Now, whenever you're talking about a rotation, you need to figure out which direction we're going to do by default. Because let's say I went 100 degrees in this direction, that is the same as 260 degrees in that direction. So going to here, we need to know, is that 100 degrees or is that 260? So unless otherwise stated, rotate counterclockwise. Anybody have any questions on that? Okay, so the process is very easy. If you can measure an angle and you can measure a distance, then this is easy. Now, that involves you being able to measure an angle. Let's make sure that you guys remember how to measure an angle. Let's say you are trying to make a 100-degree angle. Here's the point that you're making your angle around. You would have had your protractor on top of there. Now, the weird thing is it'll say 100 degrees here, and it will also say 100 degrees here. The reason being is they're trying to make it so you can measure from either side. So since we're measuring from this, the only one, or actually you answer it. Which one makes sense for an angle of 100 degrees, A or B? B. So be very careful. That's the biggest thing that people mess up on when they're doing these problems, is they'll pick the wrong one. Okay, watch this process. It's going to be difficult for me to do because I can't put a protractor on this overhead, obviously. So just watch this process. If I'm going to be rotating counterclockwise, what point will be moving first? Which one will be in like first place in the movement? L, O, or B? L, because L is furthest left. Does that make sense? Feels like it. Doesn't O seem like it's further to the right? Really? I'm going L. Okay. It doesn't really matter, but let me go ahead and show you the process. So here is the process. You first make 1/2 of the angle. So you will go over, don't do this yet, just watch. You will go from C to L. You will then go over and set your protractor right here. And you will measure 100, in this case. By the way, here's your notation. If they already used big R for reflection and they want to be lazy and efficient, but they need another R for rotation, what did they do? They just put a little r. So the notation is, it tells you you're doing a rotation. It tells you how many degrees you're rotating, what are you rotating around, and what are you going to rotate. Triangle BOL. Okay, back to what we were doing. So you have gone over and you have made 1/2 of your angle. You are then going to figure out where, in this case, 100 degrees would be, and you would finish your angle. You have done one of the two things that they tell you to do for a rotation. Make an angle as big as it's supposed to be. Now watch this next piece. For the next piece, what you need to do is you need to figure out the distance that you went to get to L and go the same exact distance to get to L prime. So you would measure it out in millimeters or something. And now you have rotated one of the 3 points. Does anybody have any questions on that process? Let's do it one more time. So now you would go from C to O. You would measure out 100 degrees. You would figure out the distance it goes to get to O. You'd go the same exact distance and you would get to O prime. Obviously, mine's not perfect because I'm just winging it. Now you have rotated O. Lastly, we would go and do B. So you would go to B. You would measure out 100 degrees. You would measure the distance to B, go the same distance to B prime. And when you connect all your points, if this was actually done right, you would have rotated the whole figure. The only place that you can mess up really is measuring the angle or measuring the length. That's the only two things you can really mess up on. Now, just so that everybody can just start practicing, look at this one. This one tells you to measure or to rotate 150 degrees. What is weird about this problem, though? What's it tell you to rotate around? M. Why is that weird? It's on the figure. So since M is on the figure, how many points will actually do you end up having to rotate? 2. Which one would you do first, L or K? Sorry, that's N. Yeah, N or K? N. So you would go over and you would make your 150 degree angle. You'd figure out the distance to N, go the same distance to N prime. Then you would go to K. You'd measure out your 150 degree angle. You go the same distance as you went from M to K. You go the same distance to go to K prime. And when you connect them, you have rotated the whole figure. So what I want you guys to do is go ahead and try these problems now. If you're having trouble with the protractor, let me know and I can give you a hand. Okay, here we go. So as I told you guys, like if you're working on, I told you I was working on my snowblower and it wasn't working. And it was either the air, it was the spark, or it was the gas. I just had to check 3 places. So let's say you do this process and it doesn't work and you're like, I don't know where to check. Instead of checking air, spark, and gas, for these problems, the only 2 places you can mess up are angle, you measured your angle incorrectly, or you did not measure your distance along the angle to find out where your prime goes. Does anybody have any questions about how to rotate if the point is not on the figure versus if it is on the figure? So this one, you would have gone from B to L. You would have measured out 100 degrees. You would have found out the distance to L, and you would have gone the same distance to L prime. And then you would have gone and done the same thing, but from B to O. And you would have done 100 degrees. And you would have found out the distance to O using millimeters or something like that. You would have gone the same exact distance to O prime. And when you connect those, you would have your figure. And notice I have gone counterclockwise. Does anybody have any questions on that? Now, if you are working on a coordinate plane, it makes life really, really easy. The reason being is because there is just a rule. Let me show you how the rule works. If you have a point, x comma y, let's do 360 because that's the easiest. If you have a point xy and you rotate a full 360 degrees around 0, 0, then where does the new point, where is it located? It was at xy, it did a full circle, where is it now? Same place, x comma y. You're probably not going to memorize that one. That's not that useful. The ones that you will use is if you rotate 90, if you rotate 180, or if you rotate 270. This only works if you're going around 0, 0. How it works, if you rotate 90 degrees, all you do is you switch your point. Instead of xy, switch it so the y comes first, and then there's the x. And the only confusing part is you have to change the sign of the first one. If it was positive, make it negative. If it was negative, make it positive. So flip it and then switch the sign of the first thing. If you're rotating 180 degrees, you leave it exactly as it was, except for change the sign of both of them. If they were positive, make it negative. If they're negative, make it positive. Questions? The next one, oh, we're switching it again. It's back to yx, but the only difference is you have to negate the second. So it will be flip, leave it, flip it. And when you're thinking of negatives, it will be negate the first, negate both, negate the second. That is how this works. This only works if you're rotating around 0, 0. Let's go ahead and do a problem. Flip it, negate the first, leave it, negate both, flip it, negate the second. And those are the only ones that you really need to memorize. Okay, when we look at this problem right here, if we have 4, negative 5, well, let's flip it. That's negative 5, 4. But remember, the rule was don't just flip it, you have to negate the first one. So if currently it's a negative 5, then what is it going to become? Positive 5. So it's 5, 4 is your actual answer. 180, the rule was leave it exactly the same, but negate both of them. So what is 4 when you negate it? What is negative 5 when you negate it? And then the last one was flip it again. So it's negative 5, 4, but negate the second one. Negative 5 stays the same, but what does 4 become? Negative 4. Does anybody have any questions about how to use a rotation around 0, 0? It's just a rule that you have to memorize. Okay, what about this? What about if they asked for the rotation notation? So let's go ahead and do this problem right here. If they say, what's the rotation that we have? Well, we could put a little r for rotation. We know that in this case, it's rotating around P, and we're doing it to triangle ABC. How do we figure out what angle it was rotated at, though? Any ideas? Correct. So we can go from P to A and P to A prime, or P to B and P to B prime, or whichever one you want to use. So in this case, I'm going to do it here. I set my protractor on top. And when I set my protractor on top here, you guys can see it already without a protractor. How many degrees is it between AP and A prime, or BP and B prime, or CP and C prime? 90 degrees. So that would be a rotation of 90 degrees around P, and you're doing it to triangle ABC. Does anybody have any questions? Okay, the last problem we got to do, and we only have 1 minute to do it. This says that you have done a rotation of 80 degrees and it wants to know what this angle is. What do you think is a good first step when you're doing this problem? Draw it out. So here would be B. I'm rotating it around K. Stick with me for just a second. And I am rotating it by 80 degrees. So here is B prime. That's 80 degrees. They are asking for what is this angle right here, X. Does anybody have any ideas about how we could figure out what X is? First off, what do we know about K to B versus K to B prime? They're the same. So if those are the same, then what else is the same? The base angle. So if that's X, then this is X. There's 100 degrees altogether. We subtract the 80 that they've already counted for. You have 100. Then how much is going to be in each one of those angles right there? What's that? 50 degrees. Okay, you guys, your homework is very short. Do not turn your homework in unless you used a protractor. Thanks.